today's a small one because most everybody is gone. So we'll just start with one right here like this, and anything you guys do today is extra credit. So if you do a practice, if you do a bonus while everybody else is finishing, it all goes to extra credit. So you have a quadratic function, and I've told you ahead of time that I'm giving you quadratic functions that are factorable, because that's the bottom level, and once we master that, we'll work our way up. So, knowing that you can factor this, what two numbers can you multiply together to get a negative 15 and then add to get a negative 2? Here's your negative 15. Just give me any two numbers that will multiply to get a negative 15. 5 and negative 3. When I add these two numbers together, will I get a negative 2? No. Is there another thing that I can try? Negative 5 and 3. If I add these two, will I get a positive 2? Yes, that's it. That's the one right there. Oh, a negative 3 or negative 5 and a positive 3. Yeah. Yeah, that would give you a negative 2. Yeah. Oh, I said positive 2? My fault. So you put these in like this and do x minus 5 and x plus 3. That adds to give you a negative 2 and multiplies to get a negative 15. Now what do you do once you have it factored out? Yeah, you can alternate these signs here and come up with your zeros. You have to set them equal to 0 and solve, but when you do that, you end up with the opposite of those. So your zeros are 5 and negative 3. Now, where that goes on your graph is the x-axis, or x-axis. You would go to positive 5 on the x-axis and then negative 3 and put a dot on each one. And I'll do that on the next slide. When I record these, even when I go back and forth, it doesn't put what I recorded in order. It goes slide by slide. So if I go over there now, it'll be out of order. Alright, so you factored, you found the zeros. Do you remember what's next?
No, that axis of symmetry.
Axis of symmetry is right. Yeah, we want to have axis of symmetry, which is negative b over 2a. Do you remember how to find the a, b, and all that stuff from your equation?
Yeah, you gotta take negative 2.
Negative 2 is what?
B.
Yeah, it's the b. And what's the a?
X. So you got to do 2 times 1.
Yeah, so we have a negative b of, or not a, well, yeah, I just said it wrong, but negative 2, because this one here is from the formula, and this one is from the actual number. So negative 2, and then over 2 times 1. Yeah, you have a double negative there, so that's 2. On the bottom you have 2, so your axis of symmetry is 1. Are there any questions about how we found the axis of symmetry? We need the vertex next. How do I find the vertex?
You gotta plug you gotta plug 1 back into your equation.
Yeah, you plug in the axis of symmetry, which in this case is 1, back in for x in your original equation. So y equals 1 squared minus 2 times 1 minus 15. We put this back into the equation. She says negative 16, so we'll have a 1 minus 2 minus 15. That's a negative 1 minus 15, which is a negative 16. Alright. But the vertex is a point. It's XY point.
So, would your vertex, would that be on the Y? Like when you put it together?
Well, the vertex is a point. It's got two numbers that goes in it.
Don't you take negative 16 and plug it back into your P?
No, you don't have to plug that back in. Remember, the axis of symmetry is x equals, and the other part of the vertex is y equals. So this is your x, and this is your y. 1 and negative 16. Your axis of symmetry is the first number that goes in the point, and what you find after you plug that axis of symmetry in here is the second number of the point. So it's 1, negative 16 on your graph that you have to make a dot on. We have a negative 16 that's going to have to pop up on the y-axis, so we have to change the scale here. So what should we change the scale to? Instead of going down by 1, we could go down by 2, yeah. Well, if you're going down by, if you let each marking down through here equal 1, then you're not going to have enough lines to put in negative 16. So instead of going down by 1s, we'd go down by 2s.
I thought you were 2, 3, but no, they go 2, 4.
Yeah, you go 2, 4, 6, 8, negative 12, negative 14, and we could put negative 16 here. And if we go down by 2s, we can fit in negative 16 right here. But what you do to the bottom half of the y-axis, you have to do to the top. So this would be at 2, 4, 6, 8, 10, 12, 14, and so on. Are there any questions about changing the scale on the graph? Here comes the vertex. It's 1, negative 16, so I'll zoom in here for this quadrant. You go over 1 and then down 16, and I need to zoom out just a little bit. There we go. You go over 1 and down 16, so make a dot on the negative 16. That's the vertex. Your axis of symmetry is a vertical line that goes right through that. So I need to zoom out a little bit more, and here's my line. The axis of symmetry is what we're putting in. The axis of symmetry is a vertical line that goes straight through the vertex. That's your axis of symmetry. Yeah, you can put that line in there. And now your zeros are going to go on the x-axis. And the zeros were 5 and negative 3. That's what you found when you solved the equation. So go over to positive 5, make a dot, and then go over to negative 3. And make a dot. You will know that you're on the right track when, if you count the distance from the axis of symmetry to each point. Like on this one, you have 1, 2, 3, 4 blocks here, and on this side 1, 2, 3, 4 blocks. So they're equal distance apart. That means you're on the right track. But now here's the part where Howard and Pemberton were getting messed up. Is that if you only have these 2 points in your vertex, you could draw your graph now, but it's probably not going to be as accurate. So what do we need to do in order to insert a couple more points in here? Right. If you want some points that are above these points here, then wherever you're at with this point, you could go over 1. And then you could go over 1 from this one. it's your choice. You don't have to go over just 1. You can go over 2 if you want. But it just depends on the scale of your graph, because if we go over this far, chances are it'll give us a number that's way out, and we can't even put it on there. The reason we go over 1 is that you have the best chance of still staying in the graph paper and putting it on there. So we have to take a look at 6 and -4. We want to plug in -4 and 6 separately into the equation we had to start with. Alright, so what was the equation? What's the original equation?
That's the first part of
Was it -15? Okay. So we determined that we're going to use this x value here, 6. So let's plug in 6 and see what we get. 6 squared minus 2 times 6 minus 15. That's a 36 minus 12 minus 15. 24 minus 15 is 9. So if you put a 6 into the equation, you get back a 9. That translates into a point of 6, 9. And that's something that you can graph up here. Go over 6 and then up 9. Alright, so here's 6. And to go up 9, 9 is going to be between 8 and 10. So we would make our dot here. So that gives us one more thing we can put our curve through. The other one was -4. So plug in a -4 and see what you get back. So again, the equation was y equals x squared minus 2x minus 15. And we're plugging in a -4. So -4 quantity squared minus 2 times -4 minus 15. So that would be 16 plus 8 minus 15. 24 minus 15 is 9. That means we plugged in -4 and came back with a 9. So we can plot that point on the graph. So go back -4, which is here, and then go up 9. So you should be even with the other point. Alright, -4, and there's going to be 9. Okay, so we have a vertex and our zeros and 2 extra points. Now if you want to be accurate with this area down here, you could plug in 2 more points. And if I wanted 2 points that were below this, would I have to go out this way? You would have to go in, yeah. So if I go in and I wanted something that was right here, because I wanted to fill in this space, you could use a -1. If you want to plug in a -1 to this one here, if you plug in -1 into this equation, you get back 1 plus 2 is 3, minus 15 is a -12. So if you put in -1 and go down 12, you would end up right here. And since I'm 2 away from this point here, 1, 2, I can go 2 in right here and make a dot at that spot, because it'll end up being the same thing.
Do we have to do that too?
You don't have to. If you can still get your graph drawn accurately without doing that, you don't have to. But on a test, you might be asked, what if you put a -1 in? What's the point that it generates that's going to be on the graph?
Well, I get how to do this now. What do you mean by that?
like if this were a test problem and you had to find your zeros, that was part of the test, and you had to find your axis of symmetry, that's part of it, and the vertex, the point, you could also say, or the question could say, if you used an x value of -1, what is the point that generates? So if I put in, on this problem here, I put in -1, and it generated a point of -1, -12. The only thing left to do is to draw the graph, and we'll see how accurate I can make this. Try to have a curve. Okay, there we go. If you get the zeros, both numbers for this problem, that's 5 points. The axis of symmetry is 5 points. The vertex is 5 points. The graph is going to be 5 points. And we'll even give 5 points for any extra 2 pairs of points that you put in on the graph that turn out to be accurate. Alright, so when you factor this, it should be, you're setting this equal to 0. So you would end up with a +6 and then a -4. But when you go to find the zeros, it's -6, 4. So if you have -6 and 4, there's 5 points. Now the axis of symmetry is -b/2a. Your b is 2 and your a is 1. Axis of symmetry is -1.
Yeah.
And the vertex, we got to plug in that -1 into the equation. So you would have 1 minus 2 minus 24. That is going to be a -1 minus 24 is a -25. So for the vertex, you should have -1, -25.
Whenever I get to the axis,
We have to change the scale of this graph, so we have to go down at least 25. I'm just going to go by 5s on mine.
It works with twos.
Yeah, you can do it with 2s because it goes down to 20.
26.
Oh no, if you do it by 2s, it
on our paper it goes.
oh, your paper has more than mine. Well, then I'm only going to go, I'll just go by 5s. So I'll have a -5, -10, -15, -20, and a -25. But I have to make certain I do the same thing on the top. So that's 5, 10, 15, 20, 25.
I didn't do that. I went 2, 4.
Well, we can do it.
You have more on your graph paper than I do on the screen. Alright, so -1, -25, that's going to be a dot that is right here. -1, -25. Now we need the axis of symmetry, and that's just going to run right down through the vertex. So here it is. And then our zeros are -6 and 4. So you have to go here and here. And then for 2 other points, you could pick just about anything. The original equation, let's see. The original equation is y equals x squared, and what else was it? Oh, it's on your paper, x squared plus 2x and minus 24. Okay. Well, I can pick some easy stuff. If I use, oh gosh, let's go out 1 and use a 5. That should be easy enough. So if I plug in 5, I'll get back 25 plus 10 is 35. 35 minus 24 is 11. And if I go out 1 like that over here, I should get the same thing back here for the -7. So I'll plot those in there. We'll go over 5 and then up 11, which is going to be just a hair above the 10. And then on this side, it's going to be the same thing for the 7. So it would be right there. Alright, so I'm going to give it a shot from right here. Now your graphs are bowl shaped. So you have to have a continuous curve through this. You cannot do the following. Don't do this stuff. Let me make a darker yellow. Don't do this. If you do that, then it's off, because it's a continuous curve all throughout. And don't bring them back in like this. I'll do this in blue. Don't bring them back in like that. They actually keep going out and expanding outward. Otherwise, you wouldn't be able to reach points like this, 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 and this.